Hi, I'm Meisa Salaita, and we're here at Georgia Pacific's Savannah River Mill, home to 5 of the world's 12 largest tissue paper machines. And they run mostly on recycled fibers like these to produce products like these. Now, to keep these machines running 24/7 and produce enough paper to make 40 million cases of product each year, the mill needs to stay in tip-top shape. So that means putting on our engineering caps to constantly maintain the facility and find ways to improve it. Let's go check it out.
Paper Machine 16 is one of the mill's 5 super wide paper machines. It's as long as a football field, heats up to 700 degrees Fahrenheit, and runs 60 miles an hour. To make up to 200 tons per day, it's got to stay in good shape.
Hi, I'm Meisa.
My friend Renee Shepard is a mechanical integrity engineer here, and she puts engineering into action every day.
I actually work on pressure vessels, tanks, and piping.
And can you walk me through that in the facility?
Sure, let's go. These are parent rolls that come off the paper machine.
So this is what we saw being rolled up earlier?
Exactly.
The wet pulp first gets pressed onto a screen to remove the water, formed into a sheet that's dried and then wound on a roll at the reel. And all of that takes only 2 seconds. After the paper hits the reel, then it heads to the winder. The final product might be light as a feather, but when it's in such huge quantities, it weighs in at nearly 20,000 pounds. Paper Machine 16 is one of the most important tools at the mill. It has to be carefully maintained so that it can keep running efficiently to make the paper products people want and need every day. And it's Renee's job to make sure it's up to par through routine inspections. Looks like there's an issue with one of the parts that manages the temperature on the machine, and it's slowing down production.
Let's start the investigation. Step 1 of the engineering design process, research. So we know there's an issue with the temperature out here. What do we do about that?
So the first step in engineering, we have to go out and actually do some field investigation to see what might be happening.
Okay, so should we go?
Let's go.
To get to the bottom of this and get this machine back up to speed, we've got to first put our engineering caps on to investigate and research the problem. But before we do that, why don't you generate some ideas of your own? So we know there's an issue with the temperature on Paper Machine 16, so we've got to engineer our potential solution so that we can fix it, and fast. So Renee, you brought me here to do that. Where are we?
We are in Savannah River Mill machine shop, and based on the field investigation, we figured out that it was the heat exchanger that was having an issue causing a temperature problem.
So you brought that down here?
Brought it down here, and so we could do further investigation on it and have a table to take it apart and take a look.
Oh, let's do that.
Let's go.
This brings us to engineering step number 2, design.
So what do you think the problem is here?
So this is the heat exchanger that we believe is causing the temperature issue. And as you can see, we've removed it and brought it down here so we can get a closer look. As an engineer, we have to go back and look at the design and the intended function of the piece of equipment, that you have cooler fluid flowing through the tubes and the hotter fluid flowing through the shell. In our case, what we were finding is that the temperature going through the tubes actually was getting too hot. So when we stop and take a look at the overall condition of the unit, it appears to be fine. So what we need to do is dig a little deeper and make sure that this is actually functioning per design.
All right, so let's open this baby up and see what's inside.
Yes, let's do it. So I have my NDE technician here, mechanic Kenny. Kenny, could you come in and help us take the ends off this unit so we can actually look inside from the shell view and see the tubes down inside? There was a lot of engineering that went into the initial design. As you can see, the tubes are very clean. We don't see any corrosion, and we don't see any plugging. So we now have the heat exchanger set up for a shell side test so we can test for a leak on the tube side. So Kenny's going to apply pressure by opening the valve to the shell side, giving us water supply. And then we'll kind of look at the
and
side.
If water comes out, then it means we have a leak.
Exactly. So we, oh
my gosh,
and we do.
Wow. How do we stop that?
In engineering, we're looking for the best possible solution of many possible solutions.
A couple options. We can actually drill the tube out. We can put a plug in there and weld it over to the tube sheet, which we might damage other tubes if we do that. And we can also machine a plug that we would put in each end of the tube. So Kenny, our NDE technician, has had the machinist machine these plugs, and notice that they're tapered because you want a tight fit, but you don't want to deform the tube.
So you just tap it in like that with a little hammer or something like that?
Exactly.
Okay.
So now we have a repaired heat exchanger.
Thanks, Renee.
Thank you.
So in engineering, there's not just one right answer, but the best possible solution. Now it's your turn to test your engineering design to see if you can find any room for improvement. So we've engineered a solution to the temperature issues on paper machine 16 to keep it as reliable and productive as possible. And now it's time to put our engineering design to the test. So Renee, what do you think? Is this going to work?
Absolutely. Since we took the heat exchanger to the shop and discovered that it had a tube leak, and we've plugged the tube leak, we've reinstalled it, and as you can see here, the temperature has leveled out and is pretty stable.
With this third step of engineering, we're putting our design to the test, and it worked. The heat exchanger is now able to maintain a constant temperature and ensure that paper machine 16 is back to its productive self.
So that's going to help keep the production line moving?
Absolutely, it'll keep the paper coming off the Yankee very quickly. And the operators will be checking this every shift, so we'll know that it's functioning properly.
So you just keep following this and we keep making paper?
Absolutely.
Well, thank you.
Thank you.
Now that's a great way to find a solution. We've used the engineering design process to identify a problem, come up with solutions, and put them into action so this mill can keep running. Remember, keep your eyes open. The wonders of steam are all around you. And until then, stay curious.